video. So in the previous video I have told you about the addition and subtraction. You must be guessing what is about this video. This video is about multiplication and division. So let us do it. So multiplication and division. Basically the instruction used for multiplication and division is going to be for multiplication it is going to be MUL, that is multiplication, and for division it is going to be DIV, division. So let us use it and see. So first I am going to make two instruction. That is, one instruction is going to be move r naught comma hash 40h. So this instruction is doing what? So let us comment it also. So this instruction making r naught is equal to 40 in hexadecimal. Then the next instruction I'm going to use it as move r1 comma hash 02. So this instruction is making r1 is equal to 02 in hex. Then next we are going to use the instruction known as multiplication. So for multiplication I already said you that MUL. So MUL. And one more thing, this programming language is not a case sensitive. You can use either capital or small. It's your wish. MUL, multiplication. And here one more thing, I'm going to show you first what the error you may find sometimes and how to debug it, and what mistakes you are going to make. I am going to show them by making the mistakes. That is, mul has, in addition we do r naught comma r1. What does the output going to be come for this? Let us see. There is no need of always building by clicking on it. There is one more build option here. You may be seeing that it is build target, build it. So now let us see what does it gives. It is showing has an error, number of operands does not match instruction, and one more is warning. This error, how to resolve it and why it is coming as an error. For multiplication you cannot use in this way. There is one more way for using the multiplication. I already told you should use the accumulator for any operation, so we must use the accumulator. In additional to accumulator we should use one more resistor known as B. In multiplication both the resistor cannot be the general purpose resistors such as R0, R1, R2, 3. In multiplication and division both the resistors must be a special type of resistor, such as one is accumulator and one more resistor is B. So let us use them. So to use the accumulator, first we should move the value to the accumulator. So move A. A is a source, and no, A is a destination, and source must be written in second. So we will write as move A comma R naught. So I will comment here what does it do. So it now A become as equal to R naught. Next, now move, I said one more resistor we should use, that is B comma R1. Let us comment it as B equal to R1. Then we are going to use a multiplication. Here I am going to show you one more mistake which you will do sometimes. As in addition we use A comma B. Let us try that, and what does the output will come, we will see. MUL A comma B. Let us see what does it gives. So it is giving again an error, that is, number of operands does not match the instruction. What does has happened here? It is giving as number of operands does not match the instruction. According to the multiplication instruction, there should be no comma in between the operands. When you give the comma, it is considering A, B has a 1 resistors, but it want a 2. So let us remove this comma and see what does it give. Now remove the comma. See, there is no error, but there is one warning, and I can ignore it or you can put as an end. Now let us debug it. There is no need of going here debug. There is one more option here, it is debug. Let us debug it. So I have debugged it, and there is no need of going for run here. There is one more option here, run. So you may be seeing here A is having the value 80. So 40 into 2, 80. But one more thing I'm going to show you, what happens when the value exceed more than 8 bits. This is included in 8 bits, so it is saved in the A register. What happens if the data is exceeding the 8 bit? Let us see what does happen. Now I will remove this 2 and I'm going to give it as 20. So these both are in hexa. So let us put it in the calculator. Take the calculator and go for the mode, and go for the base and convert the calculator into hex and type there 40 into 20. You are going to get the answer as 800. So 800 is more than 8 bit. So let us again build it, then debug it. So what does happen, we will see it, then run it. You might be saying B is having the value 8. Why does it? Because keep it in a mind, A is having always the MSB value and B will be having always the LSB value. Your MSB value is 00 and LSB value is 8. So that is why the A is having the value 00 and B is having the value 8. So it is 800 including both. Now let us see by putting it the another value. So let us try it. So I'm going to put another value, that is I'm going to put now bigger value, that is 50. So let us again build it. So then debug it. So I have debugged it. Okay. Then let us run it. So the value is coming as 40 into 50, as B is having 14 value. Let us type in the calculator and check it. So it is coming as 1400. So B is having the value 14, that is MSB, and A is having 0, that is LSB. So you might keep it in mind that A is storing the other two values. Whenever the value increase more than 8 bit, other half bit is going to be stored in the A. So let us give such a value that both must have some value. Like I will give here some value. Let us check it in the calculator. What does it going to give first? 40 into 52. Ah, this is going to give some value in both. It is giving as 14 and 80. I have given here as 40 into 52. Then let us build it. Then debug it. So I have debugged. Then let us run it. So it is giving as 40 into 52 as 1480. So that is the what I am getting the in the calculator. So this was all about the multiplication. So now let us go for a division. So in division, the instruction are going to be the same. I'm going to move R0 with a 40H and I'm going to change R1 with 2, and A is having the value 40 and B is having the value 2. Then here in place of multiplication I'm going to use the division. It also follows all the rules of the multiplication. So let us build it. So I have builded it. Now let us debug it, then run. These are the steps you must keep it in mind. So the answer 40 divided by 2 is going to be a 20. Now you might be thinking, what does the B stores? B stores the remainder and A stores the quotient. So here the remainder is 0. Let us put some value which does not give the 0. Let us put and see. Okay. Now I will put here as something value has, what should I put? I will put it as 3. So let us check in the calculator, what does it give? 40 divided by 3. So it is going to give a 15 as a quotient. Remainder is going to be, I don't know what does the remainder is going to be, but quotient is going to be a 15. You just find what is going to be a remainder. So it is builded, then it is debugged. Okay, then it is going to be run. So remainder is going to be a 1. Okay, for 40 divided by 3 in hexa. Okay, when you divide 40 by 3 in hexa, you are going to get a quotient as 15 and remainder as 1. So for multiplication and division, the rules are same. You must use this as the syntax. So that's it for today. In the next video, I'm going to make some important things such as looping concept, which is very important in this assembly language. So that's it for today. Thank you.